Now let's try to reverse the given singly linked list problem. So whatever it may be, when it comes to data structures and algorithms, one of the very much overhyped problem is reversing the given singly linked list. It is not difficult or whatsoever, just because of all the memes and all the jokes that you've been seeing on the social media. It kind of gives you a feeling that it is very much difficult to solve, but it is not at all difficult. Just try to follow the algorithm that I'm going to explain. You will never ever forget it. Okay, so that being said, let's just try to understand. You will be given an input list with some values in it. You have to reverse the given singly linked list and try to do it in the same place. That means that try to not use any additional memory in reversing process. Okay, so remember that here we will be given the head node of the singly linked list. Any node of the singly linked list will have the value as well as pointer to the next node, which is nothing but next. So that is the structure of the singly linked list node that we will be following as well. It will have value, it will have the reference of the next node in the variable name next. Now here, this is the input list that we have gotten. If at all, after reversing the given singly linked list, the output should be reversed. That means 1, 2, 3, 4, 5 are the values that we have in the singly linked list before reversing, and after reversing, obviously the output should be 5, 4, 3, 2, 1. Similarly here, these are the values in the input list and these are the values in the output list. And ultimately here, remember that input list might contain duplicates, or it might contain heterogeneous data or anything. The reason why I have mentioned this point inside the problem statement is that usually singly linked lists are usually most of the data structures are heterogeneous data structures, right? That means that they can hold any type of data in them. So that is the reason why here I have mentioned this. But nonetheless, even if your problem statement doesn't mention, you can obviously assume that singly linked list can have heterogeneous data, but it is completely up to the problem statement that I have defined here. Nothing to worry about that specific condition. And input list can be empty as well. Okay, so that is the problem statement that we have gotten. Now we need to write the effective logic for reversing the given singly linked list in place. Remember that here we have gotten a singly linked list head node. That means we can read the values that we have in every node of the singly linked list, and again we can construct the reverse singly linked list as well. But that is not the way we have to approach this problem, because the problem statement said that we have to do it in place. That means by just readjusting the nodes that we've gotten in the singly linked list, we should be able to reverse it in place. Okay, that is the problem statement. Now let's dive into how can we reverse it. Alright, so here the list that we have gotten has the values 1, 1, 2, 3, 4, 5. So if we represent it in the pictorial form of the singly linked list, this is how it is going to look. And here every node will have two variables in it. One is value and the other one is pointer to the next node in the variable next. Now we need to reverse it. For this, what we will do is we will define three variables. One is current node. In the beginning, it will be pointing to the head node that we have gotten, which is nothing but 1 that we will be getting in the function argument. Similarly, what we will do is we will define another variable called next node. This also in the beginning, it will be pointing to the head node as well. Along with that, we will define one variable called reversed list. This will hold the reference of the head node of the reversed singly linked list at any given point of time. Remember that this reversed list variable will basically hold the head node of the reversed linked list at till that point of time. In the beginning, there is no head node, right? That means that we haven't reversed anything. So here we will be initializing it with null. In most of the programming languages, we will initialize it with null. In Python specific implementation, we will be initializing it with none. Now what we will do is, as long as we have not reached the tail node, that means that whatever the current node that we have is not equal to end. How we will know? We will compare it with null. In Python, we compare it with none. So we will simply run a loop. What we will do? We will go on to the current node. So current node right now is not null, it is at 1. So what we will do is pick up the node that we are at, and this needs to be reversed, right? That means whatever the reverse list that we have so far, it will be pointing to the, it will have the reference of the head node of the reverse linked list till that point of time. So whatever the node that we pick up, it should come before, so that in the end we will have all the reversed values. So whatever the node that we pick up, what we will do, current node dot next that we have, we will be updating it with the reverse. So far it is having null, so it will have added 1 right now. Immediately we will have next nodes also, right? So we will update the next node with the current node dot next, it will be pointing to this one. Now also current node is not null, we still not have reached the end. What we will do, this is the reversed so far. So we will pick up 1 again, and 1 we will add in the front of the reversed list that we have so far. That means this current node dot next, which is 1 dot next, we will assign with reverse. As a result, the 1 will get added in the front, and the reverse list will be having this 1 in it. Immediately next is again having 2, we will pick it up, and 2, what we will do, current node dot next is equal to reversed. So this reversed will be having 1, we will add 2 here. Similarly we will move on to the node 3, and 3 will get added here. Immediately we will move on to the next node, we will add 4 here, and immediately we will move on to the next node 5, and we will add it here. Once we reach 5, current node dot next will become null, and we no longer have nodes to add. So here the final reversed linked list is nothing but 5 4 3 2 1 1. If you see 1 1 2 3 4 5 is what we have. If we reverse, 5 4 3 2 1 1 is what we have gotten. Remember that we will run the loop till we reach the very last node that we have. Basically the current node will become null or none. In the case of Python it will be none. In the case of any other programming language it will be null. So every time we pick up the node, this reversed list will have the head of the reversed linked list so far. So whatever the node that we pick up will get added in the front. That means the current node that we pick up dot next should be added with this reversed list so far. In the end, reversed we update with the current node that we are at. Okay, so that is the logic. Now let's try to do the same thing on one more singly linked list. Let's just say we have a singly linked list containing hi, bye, see you. So immediately we will start here, and this reverse list in the beginning, it will be null in most of the programming languages, none in the beginning. So we will pick up the node, and the head of the reverse list so far is null. So we pick up the node and we add the next to it. So hi dot next will be none anyway, and we will move on to the next. Okay, we will pick up by, this by will get added again, and then we will move on to the next node see you, and we will add it here. So see you by hi is the reversed list. We don't have any more nodes left here to pick up and process. Okay, very simple implementation. Just the point that you need to remember here is we will have 3 variables. Current node, it will point to the current node that we are processing. Next node is something that will help in keeping track of the next nodes that we can process, because current node dot next we are updating with reverse, right? So if we don't keep track of the next nodes in some variable, there is a chance that we might lose the track of that. That is the reason why we have here the next node variable. Okay, that being said, let's just quickly go ahead and write the pseudocode of it, and later let's try to write the programmatic implementation and validate various scenarios. Alright, now let's try to write the pseudocode. So here we will have one function called reverse singly linked list, and what it does, it will take the head node. Immediately, there is a chance that there is no node itself in the given head, right? So that means if the head node is equal to null or none, So this none check is for the Python specific learners, and this null is for all other programming language specific learners. So here, if this is the case, we did not have a valid node reference inside this head. So immediately we can't reference it, we can't return, reverse it anyway. So we can return that null or none itself back to the user. If this is not the case, like I mentioned, what we will do, we will define three variables: current node, it will be pointing to the head. Similarly, we will define another variable called next node. It will be pointing to the head node itself in the beginning. Along with that, we will define one variable called reversed. This will hold the head of the reverse singly linked list till that point of time. In the end, that is what we need to return. Because if we have the access to the head node, using the next reference, we will be able to reach the end of the singly linked list as well. So here, in the beginning, it will be pointing to a empty value, which is nothing but null, or in the case of Python, it will be none. Now what we will do, as long as this current node that we have is not equal to null or none, in this case, what we will do, we still have some nodes to process. We need to pick up all those nodes and we need to construct a reverse singly linked list out of that. For that, immediately what we will do is, whatever the next nodes that we have, this will be current node dot next, right? So we will read and keep it in one variable. Now this reverse list has head reference of the reverse linked list till that point of time. Now it needs to get added on the next of the current node that we are processing. So current node dot next is equal to the reverse list. Now the head of the reverse list is nothing but whatever the current nodes that we are processing. Later on, whatever the node that we pick up, it should get added in front of that. That is the reason why here reverse we will update with the current node. That is done so far. Now the node that need to get processed in the later iteration is there inside this next node variable, but our loop is running on the reference of the current node. So we will simply update the current node with the next node so that it can run the next iteration. Once this is done, all the nodes that we get will get added on the reverse direction, and we can simply return the reverse list reference itself, because it has the reference of the reverse linked list head node. That itself helps us in reading all the values, so we can return that. Okay, so that is the simplest implementation of the reversal of a singly linked list in place. So if we want to analyze the time complexity of this specific algorithm, obviously from very first node till the very last node we had to go. That is the reason why this while loop, whatever we have, will run for n number of times. As a result, the time complexity will be order of n. And the space complexity, if you see, we are not creating any list or whatsoever. With the simple couple of variables itself, we are constructing the reverse singly linked list in the same place. That is the reason why the memory consumed will also be constant, which is nothing but order of 1. Okay, so that is the pseudocode for the overhyped reversal of the singly linked list. Now let's write the Java logic for reversing the singly linked list. Since it is our first singly linked list practice problem that we are trying to implement, I have created a new package called practice inside the singly linked list folder, and there I have created a new file called reverse linked list. In this, basically I have added all the new classes as well as the function in which we will be writing the reversing of the singly linked list, which basically takes the head node of a singly linked list and returns the head node of a reversed singly linked list. Here I have created a singly linked list object that we have already implemented, and I have added three values 10, 20, 30. After that, I have created object of this reverse singly linked list class so that I can call this reverse singly linked list function that we are going to implement. Okay, after that, whatever the node that we are returning, the head node of the reverse singly linked list that we are returning, I'm just traversing it from head to tail. This function is exactly similar to whatever the traversal function that we have written in the case of singly linked list. This function is, this while loop is exactly similar. It's just that I want to print the every value that we have in the reverse singly linked list. I have written this while loop here. Okay, so that is something that you have to notice. Okay, now that this is clear, let's just deep dive into the implementation of the main function that we have here. So instead of just returning the head here, in the end we will be returning the reverse singly linked list head. So to reverse the singly linked list according to the steps that I have explained in the beginning, what we will do, we will basically define couple of helper variables. One is current node. This current node is nothing but we will be starting the reversal from the head node, right? So let's just define it with head node. Along with this, let's just define one more variable, next node. This basically holds the reference of the next node that we will be processing. You will see how will I use this variable once I implement the looping logic according to the steps that we have discussed previously. So here in this next node, we can simply define this also with head node itself. Even it is possible that you can initialize it with null as well. It really doesn't matter what you're going to. Along with this, to hold the reference of the singly linked list head, what I will do is I will define one variable called reversed, and this in the beginning will be pointing to null. Now what we will do is, as long as the current node that we are processing is not equal to null, that means that there are still unprocessed nodes in the singly linked list that we need to process, and we have to make sure that we need to add them into the reversed whatever we are maintaining here. So here, once we have the current node, what we will do is the next node that we need to process, we will update it onto this next node variable that we have here. So immediately next node whatever we have, we will simply update with current node dot next. Okay, so we have the next nodes that we need to process inside this next node variable. Now we need to reverse the singly linked list, right? So far whatever the reverse singly linked list nodes that are there, that are available inside this reversed variable. So all we need to do is this reverse list needs to be the next of whatever the current node that we have. So what we will do is current node dot next is equal to whatever so far we have reversed, that we will assign. Okay, so technically the updated reverse is nothing but whatever we have in this current after executing this line number 15. So we will simply update the entire reversed linked list head node is nothing but whatever the current node that we have at this point of time. Okay, now the next nodes that we need to process, the current node that we need to process is available inside this next node, right? So we will simply update this current node is equal to whatever the next node that we have here. Okay, that's it. So technically we have, once we run this while loop completely for all the nodes that we have in the singly linked list, we will be reversing the entire singly linked list. In the end, the head of the singly linked list will be available inside this reversed variable, so we can simply return that itself. Okay, very simple implementation. You just need to make sure that whatever the reversed variable that we have here, this basically holds the head node of the reverse singly linked list so far in the while loop. So as part of the while loop, as part of the first step, we will basically keep track of the next nodes that we need to process. That's the reason why we have updated the next node with current.next. And whatever the current node that we have, since we want to reverse the singly linked list, to this current node next should be whatever the reverse list that we have so far. That is nothing but this head node of the reverse linked list so far. That's the reason why we have updated that. Now completely reverse singly linked list is nothing but whatever we have in this current node. So we have updated the reverse to current node, and in the end the nodes that we need to process right now are available inside this next node. So we have updated the current node with next node. Very simple one, not at all confusing or anything. You just need to remember that this reverse basically holds the reference of the head node of the reverse singly linked list. Okay, that's all. Okay, now that anyway we have implemented this function and we have called, we have created the singly linked list object as well, and we have created the object of reverse singly linked list and called the function. And here see, I am passing sll.head, which is nothing but the very first node of the singly linked list object that we are trying to reverse. So here the singly linked list that I am passing has 10, 20, 30. So if I reverse this, Ideally the output should be 30, 20 and 10. So if I execute this, that is the output that I'm expecting. So let's see. You see on the console that we have got here, the output that we have got is 30, 20 and 10. Let's just say we are adding one more value 40. So if I reverse this, the output should be 40, 30, 20 and 10. Okay. If at all, if you want to remove couple of values, you can do, you can add as many values as you want. Ultimately it will be reversing. Okay. 20 and 10 we have got. Let's just say I want to reverse a single linked list in which we have only one value. If I try to reverse this also, the output will still remain same, which is 10. Okay. So those are some of the cases that we need to validate with respect to reversing the single linked list, and whatever the logic that we have written for reversing the single linked list is working absolutely fine for various scenarios. Okay. So that is the logic using which we will be able to reverse the singly linked list that we have been given. Okay. Even after this, if you feel you have little confusion in understanding, you can use codingpal.org's visualization panel for this reversing of singly linked list, and you can get a better clarity as well in real time how each and every variable are being updated. Okay. So I will put the link of this problem in the description box. You can use that link for checking the visualization as well as to get any of the code snippets as well. Okay. So that's it for reversing of a singly linked list. I'll see you in the next problem.